Students, I am going to solve certain problems from NCERT book of 11th standard mathematics, and we are doing the chapter called permutation combination, and it is chapter number 6, and we are going to solve now an exercise 6.4. So all the problems on 6.4 we are going to solve. Now look at the first problem. This first problem is actually based on an identity. That identity is actually like this. NCR is same as NC n minus R. Now actually when you look at it, to me at least it's very obvious statement, because what is NCR? NCR is number of ways in which R objects can be selected from N. Now if I select R objects, automatically I am rejecting N minus R objects. So the moment I select every R, I am rejecting N minus R. So total number of ways of selecting N minus R objects has to be same as NCR. But if that argument does not appeal to you, we can have a proof of this. Very simple. It's a very simple proof of this statement. Let us see. Proof. Okay. NCR. What is NCR? NCR is n factorial divided by n minus r factorial into r factorial. Right? Now, that is LHS. So this is our left hand side. Fine. Now, let us look at the right hand side. RHS. What is RHS? It is n c n minus r. What is that? That is n factorial divided by n minus r factorial into n minus r factorial. N minus r factorial. But what is that? If you simplify that, you will come to know that this is n factorial. N gets cancelled. R factorial into n minus r factorial. So right hand side is equal to left hand side. So therefore this is also equal to RHS. Okay. So RHS is equal to LHS. It is quite clear. Okay. So that is a proof of this. Now, so you should know one thing, that the binomial coefficient that I am talking about, there are what? NC0, NC1, NC2 and so on. This is NC, say n minus 1, and last binomial coefficient is NCN. So always remember, NC0 will be always equal to NCN, NC1 will be always equal to NCN minus 1. That means these two will be always equal. Why? Because NC0, NCN can be written as NCN minus 0. So therefore it will be same as NC0. Correct? So that is how these objects are there. So therefore remember one thing, that for example in this problem, now look at this problem. Problem में क्या दिया है कि NC8 is given to be NC2. Correct? So always remember one thing, that NC, say X, is equal to NCR. If I want to solve this equation, there are two solutions. Either X is equal to R, or X can be N minus R. Just remember this. Okay. So NC8 is equal to NC n minus 8. Correct? So NC8 is equal to NC n minus 8, and that means, and this is equal to what? NC2. So that gives me a relation that n minus 8 must be equal to 2. Therefore, n is 10. Correct? Now, once I know what is n, I can immediately find out NC2. So NC2 here is nothing but 10C2, and 10C2 can be written as 10 multiplied by 9 divided by 1 multiplied by 2. Correct? Which is equal to 45. So 45 is the final answer. You can verify the answer from the book itself. Okay? So this is how this problem has to be solved. So the fundamental identity is this: NCX is equal to NCR, means either X is equal to R or X is equal to N minus R. That's all. Okay. So that completes this problem. Okay. Now let us have a look at the second problem. Question number 1 is 2NC3 upon NC3 is equal to 12. I already told you 2nC3 can be written as multiplied by 2n minus 1 multiplied by 2n minus 2 divided by 1, 2, 3. That is numerator. Okay. And then denominator, similarly it will start from n, multiply by n minus 1 multiplied by n minus 2 divided by 1, 2 and 3. That is denominator, right? And this whole thing is equal to 12. So you can see here this 1, 2, 3, 1, 2, 3 gets cancelled, right? And from here 1n and 1n gets cancelled. Okay. So now what are we left with? We are left with 2 from the first bracket. Second bracket is 2n minus 1, no doubt. But in this third bracket, there is 2n minus 2 and I can take out 2 out. So it becomes n minus 1, right? Divided by, now it is, new denominator is n minus 1 and n minus 2. This is equal to 12. Now this n minus 1 gets cancelled. This 2 into 2 becomes 4. So 4 times 2n minus 1 divided by n minus 2 happens to be 12. Now let us take this 4 on this side. So 2n minus 1 upon n minus 2 is equal to 12 upon 4, which is equal to 3. And now cross multiply. So this 3. So that means now the equation is this 2n minus 1 upon n minus 2 is equal to 3. So that I can write it like this 2n minus 1 is equal to 3 times n minus 2. So 2n minus 1 is equal to 3n minus 6. So now this 2n goes on this side, this 6 comes on this side. So that means it becomes what? 6 minus 1 is equal to 3n minus 2n. That means 5 is equal to n. So value of n we have found out to be equal to what? 5. Okay. That is how the first problem can be solved. Okay. Now let us solve the second one. Let us have a look at the second problem. But I don't think second problem needs solving because there is hardly any difference, right? So we will not solve second problem. Let's go to next. How many chords can be drawn through 21 points on a circle? Okay. How many chords can be drawn through 21 points on a circle? Now suppose this is a circle, right? And there are points on the circle, say P1, P2 and so on and so forth till you reach what? P21, correct? Now drawing a chord means what? Joining any 2 points, right? So in order to draw the chord, you will have to choose 2 points, right? And how many points are available? 21 points are available. How many chords can be drawn? Drawing chord, as I said, is nothing but choosing 2 points. For example, I may choose P2 and P1 or P1 and P21 like this. And all kinds of pairs are allowed. So therefore it is 21. Out of 21, I am going to select what? 2. The total number of ways of selecting 2 points out of 21 is the number of chords. So this gives you the total number of chords. Now if you want to find this number, use my technique, start from 21, reduce it by 1, and this has to be done only twice. So it's over, divided by 2 factorial or 1 into 2 and 1 into 2, and this is equal to what? The total number of chords. But this will be 2 divided by this will be 10. So therefore 20 this will be 210, correct? So 210 is the answer. 210 is the answer. So 210 chords can be drawn. Simple. Okay. How many ways a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? Now how many girls and boys are available? So available boys and girls. How many boys are available? 5 boys here and 4 girls, right? Now, to be selected, how many are to be selected? We want only 3 boys, 3 girls. That is what the requirement is. That means I am choosing 3 boys from 5 boys and 3 girls from 4 girls. How many ways I can do it? Obviously, it is 5C3 and multiplied by 4C3. Why I am multiplying? Because both the jobs are to be done simultaneously. Whenever both jobs are to be done simultaneously, I have to apply multiplication principle. So answer is 5C3 multiplied by 4C3. Always remember, whenever this number is greater than half of this number, you can use this identity NCR is equal to NCN minus R, right? Using this, you can reduce this number, okay? That is the advantage, right? So 5C3 can be written as 5C 5 minus 3 multiplied by 4C3 can be written as 4 minus 3, correct? So that means this becomes 5C2 and this becomes 4C1. To that extent, our calculation is reduced. Now 5C2, if I want to find out 5C2, as I said, count down 5 and multiplied by 4 because we are allowed to do it only twice. So divided by what? 1 into 2. This is the numerator. This is the one part. And the second part is what? 4C1. 4C1 is nothing but 4 upon 1. That's all. So if I cancel this 2 and this 4 here, so it is 10, right? 10 multiplied by 4. Therefore, the answer is 40, correct? So there are 40 ways of selecting 3 boys and 3 girls from 5 boys and 4 girls. Okay? Is that clear? Fine. So now, okay, let's go to the next problem. Find a number of ways of selecting 9 balls and 6 red balls. Selecting 9 balls from 6 red balls and 5 white balls and 5 blue balls if each selection consists of 3 balls of each color. Okay. So we want to select 9 balls, right? From 6 red, then 5 white, and then 5 blue balls. 5 blue balls. Now, number of ways of selecting 9 balls. How many balls we want to select? 9, right? 9 balls. But the condition is that each selection consists of 3 balls of each color. So that means I will have to compulsorily select 3 red, 3 white and 3 blue. And that amounts to all the 9. So that means out of 6 red ball, 3 balls can be selected in 6C3 ways. Out of 5 white balls, 3 balls can be selected is 5C3. And out of 5, 3 blue balls can be selected is 5C3. Okay. So that completes the selection of all the 9 balls, right? So this is equal to 6C3 multiplied by, as I said, instead of 5C3, because 3 is greater than half of 5, I'll use n minus r. So that means it is equal to 5C 5 minus 3, which is 2, multiplied by, again here, 5C 5 minus 3, which is equal to what? 2. Correct? So therefore, the answer is now 6 multiplied by 5 multiplied by 4 divided by 1 multiplied by 2 multiplied by 3 in one bracket. Second bracket, 5 multiplied by 4 divided by 1 into 2, and the last bracket is 5 multiplied by 4 divided by 1 into 2. Correct? So now you can cancel this 6 and this 2 and 3, right? So the first bracket leaves us with 20, 5 into 4. Second bracket, I can cancel this 2 and this 4. So the second bracket is left with 10, right? And the third is also left with what? 10. So which means we have 20 multiplied by 100, right? That means 2000 ways of selecting so many balls. Okay? Each to the color. Fine. So that is the answer to this question. Okay? Now let us look at the problem number 6. Determine the number of 5 card combinations out of the deck of 52 cards if there is exactly one ace in each combination. Okay? So 5 card combination out of the deck of 52 cards. So out of 52 cards, out of 52 cards, we have to select how many? 5 cards. 5 cards are to be chosen from 52. Correct? Now what is the condition? There is exactly one ace in each combination. So it must contain one ace. And then they are not giving you any other condition. They are just saying that you have to select one ace. Now if you have to select one ace, then how many aces are available in a card of 52? There are 4 aces available, right? So there are 4 aces available. 4 aces are available. Out of that, you have to select one ace, right? So you can do that in how many ways? 4C1 ways, right? So this is the number of ways of selecting one ace, right? And I want 5 card combination, but out of that one card is ace, so that is already chosen. And that one card which is already chosen is not now available for the choice. So how many cards are left? One ace is already gone. So total number of cards now available are 51, right? And out of 5 cards, one card has already been chosen. Therefore, how many cards remain to be chosen? 4 only, right? So these 4 cards and this one ace. So 5C1 and 51C4. That is the answer. Okay. So that means this is equal to 4 upon 1 multiplied by 51 multiplied by 50 multiplied by 49 multiplied by 48. You know exactly 4 times I have to do this, right? Divided by 1 into 2 into 3 into 4, correct? So that means you can cancel this 4 into 2, that is 8, and that is 6 here, okay? Now this 3 can be cancelled with 51, correct? So 3. So if I cancel it with 51, say 3 ones are 3, 21 is 17, correct? So therefore, all are cancelled now. So the actual answer is the product of 4 multiplied by 17 multiplied by 50, right? Multiplied by 49 multiplied by 6. Now the final answer you can calculate from this product and all that, but that will be the given answer there. Okay. So that is how this problem has to be solved. Okay. So remember what I did. I had to select 5 cards, but out of that one was ace. There are only 4 aces available, out of which I have to select one. That means out of 5 cards, only 4 cards remain to be chosen. And out of 52 cards, one card is already gone. So only 51 cards are available. So 51C4 multiplied by 4C1, that is the answer. Okay. Now, let us look at the problem number 7. In how many ways can one select a cricket team of 11 members from 17 players, right? Of which only 5 players can bowl if the cricket team of 11 must include exactly 4 bowlers. Okay. So there are 17 players, but they are divided into 2 parts. Now bowlers and no bowlers, right? So 17 out of which 5 players can bowl. So that means there are 5 bowlers. There are 5 bowlers and remaining 12 are batsmen or whatever. I mean remaining players. So 5 bowlers. And these are non-bowlers. I mean they need not be necessary batsmen, but still, right? So that is how it is. So 12 are there. Okay. Now 11 must be exactly 4 bowlers are required here, right? So I must include 4 bowlers, but the team is consisting of 11 members. So now exactly 4 bowlers are required out of 11. So how many players are remain to be selected? So 11 minus 4, that gives you 7, right? So 7 plus 4 is a selection of what? All the. Now out of 5 bowlers, you are going to select 4. So that can be done in 5C4 ways. Okay. Multiplied by, this can be done in 12C7 ways. Again, this 4 is greater than half of 5. 7 is greater than half of 12. So I'm going to use the identity NCR is equal to NCN minus R to make my calculations easier. So this becomes 5C, 5 minus 4, and this becomes 12C, 12 minus 7, right? That is equal to 5C. Now 5 minus 4 is 1 multiplied by 12C, 12 minus 7 is 5. Okay. So 5C1 is simply 5 upon 1, correct? 12C5 means what? 5 times I have to go backwards. So 12 multiplied by 11 multiplied by 10 multiplied by 9 multiplied by 8. 5 are over, right? Divided by 1 into 2 into 3 into 4 into what? 5, correct? So this 5 and this 5 will cancel it, okay? Now this 3 and 4 is product is 12, so this 12 also goes. This 2 and this 8 goes, so here it is what? 4. So that means we are left with what? 11 is left as it is, 10 is left as it is, 9 is left as it is, and instead of this 8, only 4 is left. So the product is what? 110 from the first to 36, right? So you can calculate this answer. 0, 36 into 1, 6, calculated 30, 36 plus 3, 39. So this ought to be the answer of the problem, okay? A bag contains 5 black, 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. 5 black, correct, and 6 red. These are the balls available. And what is to be done? 2 black and 3 balls can be selected. So 2 black and 3 red balls can be selected. Again, the answer is very simple. 2 black balls can be selected out of 5 in 5C 2 ways multiplied by 6C 3 ways, correct? 5C2 can be written as 5 multiplied by 4 upon 1 multiplied by 2, and 6C3 can be written as 6, 5, 4, 1, 2, 3. So 1, 2, 3 means 6, 6 gets cancelled. Here this becomes 2. So the answer is 10 multiplied by 60 here, right? So answer is 600. Okay, that is the answer to this problem number 8. Okay, fine. So now let us go to the next problem. Okay, so what is the next problem? In how many ways can student choose a program of 5 courses if 9 courses are available? 2 specific courses are compulsory for every student. Okay. Now there are 5 courses. If 9 courses are available, so 9 courses available. 2 specific courses are compulsory. That means these 9 courses are actually divided into 2 parts. The 7 courses, they are not compulsory, but 2 courses are compulsory. So these are compulsory courses. These are non-compulsory, right? So 2 courses are to be chosen. So there is no option for them. Every student has to select what? These 2 compulsion courses. Therefore, and how many courses are to be chosen? 5 courses are to be chosen. Out of that, 2 courses are compulsory. So only how many courses remain to be chosen? Only 3 courses. And that also from the remaining. So here there is no chance, because out of 2 you are going to select 2. So 2C2 is nothing but what? 1, right? So forget about that. Now these 7 courses are available, and out of 5, 2 are already taken. So the answer is 7C. 3 courses are to be chosen. Finished. So the answer, again I'll repeat, out of 5 courses, 2 are compulsory. So these 2 courses are compulsory courses. They have no choice. This can be done in only one way. So choose them. So only 3 courses remain to be chosen from the remaining 7 courses. So the answer is 7C3, which can be written as 7 multiplied by 6 multiplied by 5 upon 1 multiplied by 2 multiplied by 3. This gives me This 6 gets cancelled with the denominator, and the answer is what? 35 courses. Okay. So that is the answer to the problem number 9. Okay. So now student, what we have done is, we have done some, I remember one thing, these are very, very elementary problems, right? And I don't think the problems of this type will be asked in the competitive exams. No, these are very elementary problems. If you want to study some better level problems, some problems which are generally asked in competitive examination, then please attend my next lecture, where I'm going to solve slightly difficult problem, not very difficult, but slightly difficult, suitable for JEE main or something like that. Okay. So till that time, goodbye.